The Sodera Wideband Protocol Analyzer can capture and analyze wired signals as well as wireless traffic. In the Logic Analyzer, wired TTL type signals are displayed with classic and low-energy Bluetooth packets. You can make accurate relative time measurements between the logic signals and the Bluetooth packets. The first step is to assemble the hardware to capture wired signals. Now, with the Frontline software started and the Sodera attached to the computer, set up the wired capture in the Capture options. Select the Wired tab and check Pod 1 and Pod 2 as the wired source for logic signals. Finally, select Analyze Logic Signals. Now click the Record button to begin capture for logic signals. In the Wired Devices pane, select Pod 1 and Pod 2 to analyze. After signals are recorded and sources selected, click on the Analyze button to send these selected signals for analysis. In the frame display, there is a Logic Signal tab with the Protocol tabs. If you did not select Analyze Logic Signals in the Options menu, this tab does not appear. Clicking the Logic tab displays the logic signal packets in the summary pane. Within a frame, logic high state is shown as an H and logic low state is shown as an L. If the logic state has changed from the previous packet, then an asterisk appears with the logic state. When you select a frame, this information appears in expanded form in the decoder pane. Let's stop and take a brief aside here to talk about frames when capturing logic signals. When you're capturing logic signals, they are converted to a frame by our decoders. In this view, we see frames 1 and 2 as logic frames, and we see frame 3 is a Bluetooth frame, 4 through 7 are logic frames, and frame 8 is a Bluetooth frame, so forth. The point here is that you will notice in your analysis that when looking at Bluetooth frames, the frame numbers are not necessarily consecutive. That's because we have logic frames interspersed. If we were not capturing logic signals, then we would see frame 3 and frame 8 would be consecutive, and they would have consecutive frame numbers. This is important when you're doing your analysis, that you understand that in certain displays you're going to see non-consecutive frame numbers for Bluetooth signals or non-logic signals. Take this into account. Now, to open the Logic Analyzer, click on the Logic Analyzer icon in the toolbar. When the Logic Analyzer first opens, you may see hashed bars. These Hashed areas indicate that the signal cannot be resolved in the display because we have zoomed out too far. In the navigation pane, the viewport, the yellow area, controls the timeline view. By decreasing the width of the viewport, you zoom in. In the Tools bar, the Zoom In button will decrease the viewport and will give you more signal resolution. And when you click and drag with the left mouse button in the timeline view, you can move the viewport in small changes. In the timeline view, logic signals appear as high-low levels. Bluetooth packets appear as a rectangle with the length representing the packet duration. Packets are annotated with the packet type and the frame number. Classic Bluetooth packets appear as blue rectangles, and low energy packets appear as green rectangles. Packets outlined in a dashed yellow line have been selected in the frame display. A timeline row contains all captured packets from a single Bluetooth device. You can make relative time measurements between logic transitions, packet edges, or both. The cursor tool provides this feature. The start cursor is set with the left mouse button. The stop cursor is set with the right mouse button. The time between start and stop is displayed as a white dashed line that is relocatable. When a cursor pair is created, a marker is set in the navigation pane. Should you need to move off your working view, you can quickly return by moving the viewport to the marker. You can overlay one timeline row over another row using the Overlay Signals mode. Just drag the row tag to overlay over a target row tag, holding the mouse key down. The top row will remain translucent. Rows can be rearranged by dragging and dropping row tags. A line will show where the tag will be located.